Welcome to the video on symmetrical property of T network. First, let us see the Z parameters of T network. The Z parameters of a T network are Z11 is equal to Z1 plus Z3, Z12 equal to Z21 equal to Z3, Z22 equal to Z2 plus Z3. So this is a T network structure where this is Z1, this is Z2 and this is Z3. In symmetrical network, Z11 equal to Z22. So in T network, the symmetrical condition will be satisfied if Z1 is equal to Z2. So it is given here. Okay, now let us see the derivation of Z parameters of this T network. To determine the Z parameters of a T network shown in figure 1 and also express the parameters of T network in terms of Z parameters. So let us see the solution for this. The equations defining Z parameters are V1 is equal to Z11 I1 plus Z12 I2. This is the first equation. V2 is equal to Z21 I1 plus Z22 I2. This is the second equation. So to determine Z11 and Z21, let us connect a voltage or a source of voltage V1 to port 1 and leave port 2 as open circuit as shown in figure 2. So this is the figure 2. See, source of voltage V1 is connected to port 1 and port 2 is left open circuit. So now I2 is 0. We don't have the current I2 since it's an open circuit. When I2 is equal to 0, from equations 1 and 2, we get Z11 equal to V1 I1 and Z21 equal to V2 I2. Since I2 equal to 0, we don't get the I2 terms. Now with reference to figure 2, by KVL we get V1 is equal to Z1 I1 plus Z3 I1. So if you bring I1 commonly outside and bring it to the other side, we get V1 by I1 which is equal to Z1 plus Z3. This is nothing but the driving point impedance at port 1, which is Z11 is equal to V1 by I1, which is equal to Z1 plus Z3. With reference to figure 2 by KVL, we get V2 is equal to, V2 is a voltage here, the voltage which we get is Z3 into I1, okay. So this is the forward transfer impedance, Z21 is equal to V2 by I1, which is equal to Z3 here. So now to determine Z22 and Z12, let us connect a source of voltage V2 to port 2 and leave port 1 as open circuit. So now I1 is 0 here, okay. So I1 becomes 0 and when I1 is 0, from equation 1 and 2 we get Z12 equal to V1 by I2 and Z22 is equal to V2 by I2. Okay, since I1 is 0, we get that. Okay, this is going to be I1, okay, not I2 here. With reference to figure 3 by KVL, we get V2 is equal to Z2 I2 plus Z3 I2. Okay, so if we bring I2 commonly outside and bring it to the other side, we get V2 by I2 is equal to Z2 plus Z3. The driving point impedance at port 2, that is Z22, is Z2 plus Z3. With reference to figure 3 by KVL, we get, what is V1 here? We get it as Z3I2. So that is nothing but the reverse transfer impedance Z12, which is equal to V1 by I2, which is equal to Z3. So it is observed that Z12 and Z21 are equal. See, Z12 and Z21 are equal to Z3. So the network is a reciprocal network and this is due to the absence of a dependent source. So we get the Z parameters of a T network shown in figure 1. So which we saw in the very first slide, that Z11 is equal to Z1 plus Z3, Z12 equal to Z21 equal to Z3 and Z22 is equal to Z2 plus Z3. So in the symmetrical network, Z11 will become equal to Z22. In this T network, the symmetrical condition will be satisfied if this Z1 becomes equal to Z2. Okay, so instead of Z1, if you replace with Z2, this Z11 and Z22 will become equal. So this is the symmetrical property of a T network. Thanks for watching.